Okay, in this next chapter we're going to be talking about solving quadratic equations and working with quadratic equations in one variable and two. Most of you have had experience solving quadratic equations by factoring. This is probably going to be review. But some of the other methods that we're going to talk about may be new to you. As a review, if you're trying to solve a quadratic equation by factoring, you want to, if necessary, simplify both sides of the quadratic equation and then get one side of the equation to equal to 0. So before you do any kind of factoring, you should have, these first two steps here basically are to get your quadratic equation into the form of ax squared plus bx plus c equals 0, where a, b, and c represent real numbers. And so once you have your quadratic equation, degree 2 equation, looking somewhat like this, then you can go ahead and factor, and your solutions are going to be the values of x, or whatever the variable may be, that make the factors equal to 0. The reason for doing the factorization is so that you end up with a product equal to 0. And we'll discuss why that is so. So if you have something times something is equal to 0, then obviously your solutions are going to be the values that make those factors, that something times something, equal to 0. The only way you can get a product equal to 0 is if your factors equal 0. Also, just as a general reminder for factorization, always when you're factoring, you should look at the expression that you're given to see if there is a greatest common factor. If all terms are divisible by the same variable expression or number. And if there is a common factor, you should always factor it out first. And then how you go from there depends on the number of terms that you have. So if you're working with something that has 4 terms, you're going to use the grouping method. And we're not going to see any like this right now. We're going to be working just with 3 terms and 2 terms. The method that I use for factoring when I have 3 terms is I try to find 2 binomials that multiply to give me that trinomial. And I just use guess and check to figure out the factorization if it is factorable. And then lastly, if it's 2 terms, your binomial, 2 terms, is only going to be factorable if it is one of those special binomials. So this is a lot of review here, but a binomial is and then make sure everything's factored. Moving on to the binomials. These are the conditions under which your binomial, your 2-term expression, is factorable. It is factorable if there is a greatest common factor, or if it's a difference of squares, a difference of cubes, or a sum of cubes. If your binomial doesn't meet one of these 4 conditions, then that binomial is not factorable. So when you're working with solving a quadratic equation by factoring, you can only use the factorization method if you are working with an expression that is factorable. So let's do some examples and then we'll go from there. So if I want to solve this equation, so degree 2, I've got an x squared. So I'm going to try to solve this quadratic equation by factoring. Okay? And the method that I have outlined here, this is the, I can't get my braces. This is the factoring method. Okay? So simplify, meaning, and when I say simplify here, I'm saying if there are parentheses to get rid of or like terms to combine, you would want to do that. In this case, there's no simplification. Get one side equal to 0. It's already equal to 0, so I don't need to worry about that second step. I'm already basically in the position I need to be able to factor. So if I want to factor this expression, I have 1, 2, 3 terms. Okay, first of all, regardless of the number of terms, I want to look at each term. 2, 13, and 7, are all three divisible by a common factor? No. X squared, x, no x's. They don't all have x's, so these three terms do not share a common factor. So there is no GCF that I can factor out. Now I look at it's got three terms. So anytime it has three terms to factor, I'm going to try to write it as the product of two binomials. So this binomial times this binomial, I want to multiply to that expression. And I'm going to use guess and check to see if I can find two binomials that will multiply to 2x squared minus 13x minus 7. So my guess and check is always this first times first has to equal the first. So when I multiply these two terms together, I need it to be 2x squared. The only way you can multiply to get 2x squared is multiply the 2x by x, or x by 2x, either way. Also, the product of these last two terms has to equal the product of that last term. So first times first is the first, last times last is the last, and it's a -7, so I know to get a negative when I multiply, I have to multiply a positive by a negative. And also, to get 7, my only options are 7 and 1. Okay, so as I have it now, when I multiply these two terms, I get this. When I multiply the 7 by the -1, I get the -7. And then my check to see if this is the factorization is that inner and outer has to add to this -13x. Whoops. So, when I multiply 7 by x, that gives me 7x. When I multiply 2x by -1, I get -2x. And when I add 7 and -2, that gives me 5. So this does not match that, so this is not the correct factorization. So what I'm going to do is I'm going to instead, so if it doesn't work, then I just take these two numbers and I switch them around to see if it works in the other way instead. So I'm going to put the 1 here, and I'm going to put the 7 here, and then I'm going to recheck to see if I get the correct value for my inner plus outer. So when I multiply 1 by x, that gives me x. And when I multiply 2x by -7, I get -14x. And the sum of 1 and -14 is -13. So this matches this, so I know that I have the correct factorization. So what I have right now is 2x plus 1 times x minus 7 is equal to 0. So I have this times this is equal to 0. And I know that the only way mathematically I can get a product of 0, the only way I can multiply two things and get it equal to 0 is if at least one of those two values is 0. So my solutions are going to be any numbers of any values of x that make those factors equal 0. Okay? So let's look at this one here. If x equals 7, then I'm going to have 7 minus 7, or 0. And over here, I'd have 2 times 7 plus 1. I'd have 15 times 0, and that would equal 0. Okay, so it doesn't matter what this one is going to be. It just matters that I have at least one of my factors equal to 0. So 7 is the solution. Also, if I have a number that makes this factor equal 0, this product will equal 0 as well. So if you're looking at this and trying to decide, okay, what would x have to be so that 2 times that number plus 1 gives me 0, you can always just take the factor, set it equal to 0, and solve to find your solution. So I can take my 2x plus 1 and set it equal to 0 and solve that equation. So to get x by itself, this is just a linear equation, so I just isolate the variable. I would subtract 1 from both sides. So I have 2x equals negative 1, and divide both sides by 2, and I would get that negative 1/2 is a solution. Also, you shouldn't need to do it with the other factor. We've already decided 7 is the number that makes it equal to 0. But if you take that factor and set it equal to 0, solving for x does verify that 7 is a solution. So my solution set consists of the numbers negative 1/2 and 7. These are the values of x that make that statement true. Okay? You can check it. If you put negative 1/2 in here, 2 times negative 1/2 is negative 1, and negative 1 plus 1 is 0, and 0 times anything does equal 0. Also, if you put 7 in, 7 minus 7, that's 0, and anything times 0 is 0. So for the product to equal 0, the factors must equal 0. At least one of the two factors must equal 0. So that's how you factor if you're working with 3 terms. You just do guess and check. Okay? Here, 2x squared minus 6x equals 0. So again, there are no parentheses to get rid of or like terms to combine, so it's already a simplified quadratic. It's already equal to 0. So again, these 2 steps I don't need to worry about. I'm already set up for or ready to do my factorization. So I have 2x squared minus 6x equals 0. And I want to solve by factoring. So regardless of the number of terms, there are 2, but regardless, you should always look for a greatest common factor first. 2 and 6 are both divisible by 2. X squared and x are both divisible by x. So the GCF for here, I do have a GCF, and that GCF is 2x. And so if I factor that out, I would have to multiply 2x by x to get 2x squared, and 2x by negative 3 to get negative 6x. So I have 2x times x minus 3 is this expression with the GCF factored out. Okay? If inside these 2 terms, if I had a difference of squares, a difference of cubes, or a sum of cubes, I would go further. But in this case I don't, so I am fully factored. So I have 2 times x minus 3 equals 0. So our solutions are any numbers that make this product equal 0. Okay? So this product is going to equal 0 if x equals 0, because I'll have 2 times 0 times negative 3, which is 0, or the number that makes this equal 0 is 3. 3 minus 3 is 0, and if I multiply anything by 0, that product is 0. So my solutions are 0 and 3. Okay? Next one, x squared minus 18. So if I'm trying to solve this quadratic equation, again, degree 2, if I'm trying to solve that quadratic equation, oftentimes I think about factorization first. Okay? You can only use the factorization method if what you're dealing with is factorable. So the first question is, you need to ask yourself, is this factorable? Okay? And so when I'm looking at this expression, first of all I look for GCF. 1 and 18 are only divisible by 1. Factoring out a 1 does nothing. Here I have x's, here I don't. So there is no greatest common factor. Then I notice that it has 2 terms. Okay? 1 term, 2 terms. And if we go back to the beginning, conditions under which a binomial is factorable. It's factorable if there is a GCF, which we've already decided there is not. Difference of perfect squares, difference of cubes, or a sum of cubes. Okay, let me write down what I have here. So we're trying to think or decide if x squared minus 18 is a factorable binomial. Okay, so there's no greatest common factor. Difference of perfect squares would mean that you would have a perfect square, a number that's a perfect square, minus, that's where the difference comes in, another number that's a perfect square. We've been dealing with the perfect squares a lot. X squared is a perfect square. 18 is not a perfect square. So x squared minus 18 is not a difference of perfect squares. It's not a perfect square minus a perfect square. Similarly, difference of perfect cubes would be perfect cube minus perfect cube. Neither of these are perfect cubes. It's not a difference of two cubes. Sum would be, it would have to be a plus versus a minus. So it's not a sum, nor is it perfect cubes. So x squared minus 18 does not meet this condition, nor this, nor this, nor this. And in the world of binomials, if it doesn't meet one of those four conditions, then this is not factorable. Okay, it is not one of those special binomials that will factor. So if I go back to where I was, I'm trying to solve this quadratic equation, and the only method that we have at this time is the factorization method. So, it might be going through your mind, all right, well, so it's not factorable, and because it's not factorable, therefore, we cannot solve using the factoring method. Every quadratic equation is solvable. Okay, it's now going to be a matter of finding the right method that you can use. So, can I use another method? And of course, the answer to that is always going to be yes. No matter what quadratic equation you are trying to solve, you can always find another method. Another specific method is solving by extracting the root. So if you're working with a quadratic equation where it is possible to write that equation as something squared equals a number, then you can solve by extracting the root. Okay? So it is possible to solve by extracting the root if your equation can be written in the form of something squared equals a number. Because then we can take the square root of both sides and we will have our something equals plus or minus that number. So going back to that x squared minus 18, some reason that's upside down. So we could not factor, but can we rewrite it so that it has the form of something squared equals a number? We can if we get the 18 on the other side. So we have x squared minus 18 equals 0. If I add the 18 to both sides of the equation, I have something squared equals a number. And if you can write it in that form of something squared equals a number, then you can solve by not really, but we say take the square root of both sides. So if we take the square root of both sides, we have x equals, now this is what your solutions are going to be. Okay, here we have x squared equals 18. So our solutions are going to be any numbers that we multiply twice to get 18. And so because if you multiply a positive number twice or a negative number twice, you end up with a positive, you have to use both the positive and the negative root when you're solving these equations. And square root of 18, 18 is not a perfect square, but it is divisible by 1. So we can break this apart. 18 is divisible by the perfect square 9, and the square root of 9 is 3. So my solutions are both positive and negative 3 root 2. When we write plus or minus, we're saying positive 3 root 2 is a solution, negative 3 root 2 is a solution. If you were to write these out separately, you would say 3 root 2 or negative 3 root 2. Those are the numbers that satisfy this equation. And if you try it, if you multiply 3 root 2 by 3 root 2, you end up with 3 times 3 is 9. The square root of 2 times the square root of 2 is the square root of 4. And that square root of 4 is 2. 9 times 2, you do get 18. Similarly, if you multiply negative 3 root 2 by negative 3 root 2, you also get positive 18. So both positive and negative are your solutions. So when you're solving by extracting the root, when you take the square root of both sides, you do need both the positive and the negative root as part of your solution set. So when I'm looking at this equation here, I have x minus 5 quantity squared plus 10 equals 34. So in order to solve, at this point we have two methods. And we really have to decide what is going to be the most appropriate method for us to use. So do we want to solve by factoring? Or do we want to solve by extracting the root? Okay. To solve by factoring, we would have to first simplify. So I would have to square the x minus 5. So I would have x minus 5 times x minus 5, which is x squared minus 10x plus 25. Then I'd have to combine like terms, and then I'd have to get one side equal to 0. And then I may have an expression that's not even factorable. Okay? So to solve by factoring, it would require a lot of work just to get it into a form that's ready for factorization. So if that's the case and I can use another method, I typically try to use that other method. Again, you can solve by extracting the root if you can get your equation into the form of something squared equals a number. And when I'm looking at this, I see that if I can subtract 10 from both sides, then I will have something squared equals a number, and I'm all ready to then take the square root of both sides. So in my opinion, I would immediately go this route. Okay, so if I have something squared, so if I subtract 10, then I'm going to have x minus 5 quantity squared equals 24. So once you have something squared equals a number, then you can take the square root of both sides. So we have x minus 5 equals, don't forget you need both the positive and negative root. 24 is divisible by 4, the perfect square 4. So I would break this into the square root of 4 times the square root of 6, which is 2 root 6. And now we just have a basic linear equation, just x to the first power. So So to solve for x, we just need to isolate it by adding 5 to both sides. So when we add 5 on both sides, we have x equals, these are not like terms. Here you've got a root 6, here you do not, so you cannot combine. The best you can do is write this as 5 plus or minus 2 root 6. And we typically put the plus or minus part second. It is, equivalent to write plus or minus 2 root 6 plus 5, but I see too many people making mistakes. So from this, I see that 5 plus 2 root 6 is a solution to this equation. And also 5 minus 2 root 6 is a solution. And based on the types of solutions I'm getting, these are irrational numbers. Based on the fact that I have irrational solutions, that tells me that this is not something that would have been factorable. So if I had gone through this whole process, I still would have gotten to a point where I haven't had an expression that would not be factorable. So in this case, this actually would not have been an option. Okay? The only types of quadratic equations that you can solve by factoring, using the traditional sense of factoring that is, would be those that have rational solutions. No i's, no roots. So 5 plus 2 root 6 is a solution. Also 5 minus 2 root 6 is a solution. Okay? Just because we have fractions doesn't change anything. It's still a quadratic equation, and I have it in the form something squared equals a number. So to solve this for x, I am going to take the square root of both sides. I've already got it in the form something squared equals a number. So I have x plus 3/4 equals plus or minus. When I take the square root of a negative, I'm going to have an I. And then the square root of 25 over the square root of 16. So the square root of 25 is 5. The square root of 16 is 4. So this is plus or minus 5/4 I. And then the last step to get x by itself is to subtract 3/4 from both sides. So in this case, I have two complex solutions. One solution is negative 3/4 plus 5/4 I, and the other solution is negative 3/4 minus 5/4 I. Okay. Here we've got x plus 3 quantity squared minus 11 equals 38. So again, I can try to solve by factoring, but easier it's just I have the ability to get it into the form of something squared equals a number. So I'm going to go ahead and add 11. Try to get that not blurry. I'm going to add 11 to both sides. So I have x plus 3 quantity squared equals 49. Taking the square root of both sides, I have x plus 3 equals plus or minus 7. Subtracting 3 from both sides gives me negative x equals negative 3 plus or minus 7. So one solution is going to be negative 3 plus 7, which is 4. The other solution is negative 3 minus 7, or negative 10. So no i's or roots here. You can do that math and come up with your solution set. So 4 is a solution, as is negative 10. And the fact that I ended up with rational solutions, solutions with no i's, no roots, tells me that I actually could have solved this equation using the factoring method. I still would not want to because it's more work than is necessary. The fact that I could add 11 and get it into the form something squared equals a number made it easier for me to just solve by extracting the root. Last example, we want to solve this equation, 2x squared minus 2x equals 144. So we've been solving by extracting the root, and we can solve by extracting the root anytime we're solving an equation that we can write something squared equals a number. Having this term here, this 2x, makes it, at this point, until we learn how to complete the square, at this point it makes it impossible for us to do something squared equals a number. Okay, so the solving by extracting the root at this time is not an option. So I'm going to, based on the two options that I have, either solve by factoring or solve by extracting the root, solve by factoring really is my only option at this time. So to solve by factoring, I want to simplify. So when I'm looking at this equation, I have no parentheses to get rid of, nor do I have like terms to combine. So what I'm going to do is go ahead and get one side equal to 0. So I have 2x squared minus 2x. I'm going to subtract the 144 from both sides. So that's minus 144 equals 0. Okay, and then next, looking at this, 2, 2, and 144, there is a numeric factor, a common numeric factor of 2. So when your GCF is just a number and there's no x included, you can either just factor the 2 out, or easier yet would be to simply use my multiplication property of equality and divide both sides by 2. So when you divide both sides by 2, that's like dividing each term. So we end up with x squared minus x minus 72 equals 0. And what we have now is an expression, x squared minus x minus 72, which is much easier to factor than the 2x squared minus 2x minus 144. So doing my factorization, I have 3 terms here, so I'm going to try to write that this product of 2 binomials. This times this has to equal x squared, so that would be x and x. Last times last has to multiply to negative 72, so I'm going to try plus 8 minus 9. A positive times a negative is a negative. And then my check, when I multiply these two, I get 8x. When I multiply these two, I get negative 9x. And 8 and negative 9 is negative 1x. So this matches this, which tells me that that's the correct factorization. So now that I have it in factored form, the solutions are easy to find. Any number that would make this times this equal 0. So if x is either negative 8 or positive 9, that product will be 0. So these are my solutions to that equation. So that's 2 of the 4 methods that we're going to talk about. After this, in the next section, we're going to look at continuing on. We're also going to talk about solve by completing the square, and then also solve using the quadratic formula. So try these 2 methods out first, practice with these, and then we will go on. Let me know if you have any questions.